Hello everyone. Welcome back to the lecture series of Basic Electrical Engineering. In this session, I am going to discuss the model question paper for the subject Introduction to Electrical Engineering. It's a new scheme. It is effective from 22nd onwards. So I'll be discussing the particular question with the help of data handbook. If you belong to Visvesvaraya Technological University, they are providing one data handbook. So let me explain how to solve this question with the help of those data handbook. So let us get started. First of all, we will be discussing about the questions from module 1. So kindly go through the first question. So we can read the question. Question number 1A. With a neat single line diagram, explain the various steps of electrical power transmission and distribution system. Here you need to explain about power generation, power transmission and power distribution, and mention the specification carefully. For example, for generators, you have to mention 11 kV. The generating voltage is restricted to 11 kV. If I talk about the power transmission, you have to specify why high voltage power transmission is required for minimizing the transmission line losses. Again, power transmission will be segmented into two, primary power transmission as well as secondary power transmission. So when it comes to the distribution, you need to mention about the primary distribution for industrial customers, for secondary distribution for domestic customers. Do specify the voltages exactly. So that is the major thing. 6 marks means you will be getting 3 marks for diagram, another 3 marks for explanation. So this is a pure theory question. Another one is actually state and explain Kirchhoff's current and voltage law. Here I will show you the data handbook. I think you can see the screen properly. So one data handbook is given with you. So you can see a number of formulas. Starting itself, you can see the formulas of Ohm's law, right? So the relation, very, very easy actually. Even units also mentioned. So let me check it up. Yeah, the question was state and explain KCL and KVL. Here you can see directly statement is available. See, what is the statement of KCL? The algebraic sum of all the currents meeting at a junction or node is equal to 0. Here circuit is provided and here equation is also given. So very easy. You can directly refer this data book and mention the answer. Try to elaborate because this is only the points which is for your reference. So I request everyone to elaborate it. Fine. Then KVL also directly provided. So what is KVL? The algebraic sum of all the EMF and the voltage drop in a closed loop of an electric circuit is equal to 0. For your reference, they have given one circuit diagram. Even it's a series circuit and there is a loop formation and they have clearly explained how to apply the KVL. Fine. So easily you can elaborate it. Try to elaborate. Don't directly copy, but try to elaborate it. So moving on to the discussion. Another question is a numerical example. It's related to the power, then energy, then series parallel circuit. If you know that particular concept, you can solve it very fastly. The two parallel resistors having the resistance of 20 ohm and 30 ohm, which is connected series with the 15 ohm. So what you can do is 20 ohm. I have drawn 20 ohm. Then you need to draw 30 ohm, right? 30 ohm. Then another resistor which is series with the particular circuit, that is 15 ohm. 15 ohm. Okay. Then you can apply. Definitely there is a source requirement. Otherwise it won't work. So let me mention V or E. This is your current. What they have given. If the current flowing through 15 ohm resistor, and this combination will be same only because collectively this is a series. See, if I talk about 20 ohm and 30 ohm, this is one particular segment. 15 ohm is another particular segment. So both are in series only. All right. So the same current flows through entire circuit. So let me mention about the total current is 3 amps. So you need to calculate the current in 20 ohm and 30 ohm resistor. So you can directly apply current division formula. Similarly, voltage drop across the whole circuit. So you can apply the formula. So how to apply the formula, I will tell you. So first of all, you need to calculate the total resistance. You have to calculate. R equivalent you can calculate. R equivalent you have to calculate. So you can check the basics. I will show you the data handbook. So you need to know what is parallel circuit. See, one circuit diagram they have referred for you. How to calculate the total resistance. Very easily you can identify. Even current division formula which is required for solving this problem. See how to calculate I1 and I2 which is flowing through the respective branches. So refer this formula first. Kindly note down this formula. Okay. So definitely, though your answer is wrong, the evaluator may give some amount of some credit based on the formulas. So try to follow. Even power dissipation equation for power dissipation is also given. This equation we require. First of all, I request everyone to note down this formula. Later you can easily solve. Okay. So let us come back to the numerical example. So after noting down the formula, you need to come back to the numerical example. Yes, what you can do is first you calculate R equivalent using the formula. Later, what you can do, you need to calculate the current flowing through 20 and 30 ohm resistor. So let me call current flowing through 20 is I1 and the current flowing through 30 ohm is I2. Use the current division formula. I1 and I2, you can use the current division formula. I'm not solving, try to solve it. So using the current division formula, current division rule. Easily you can identify. Later, voltage across the whole circuit. This is you are supposed to calculate. How to calculate the voltage across whole circuit? So you know V is equal to I into I means the total current. It is 3 ampere into R equivalent. R equivalent you can calculate now. 15 plus 20 into 30. 20 into 30 divided by 20 plus 30. Like that you can calculate. Fine. So you'll be getting the total voltage. Similarly, you need to calculate the total power and the power consumed in all resistors. The total power, what is the formula? P is equal to V into I. Anyway, V I am getting here. So I already available in the question. So directly you can multiply both, you will be getting total power. Moreover, each resistor you have to inspect it. So for 20 ohm resistor, you can write a P20 ohm. How to calculate the power consumed in 20 ohm? What's the formula? P is equal to I square into R. I square into R20. What is the value? 20 only. I square into 20. Similarly, P30. So I square into 30. Similarly, 15 also you can calculate. Like that, you can easily follow. It is very simple question only. Okay. I hope you understood how to solve this. Anyway, data handbook is available. If you are belong to VTU, fine. So now let me come back to another question. So question number 2A. With a block diagram, explain the hydropower station. You have to explain about a dam, then you have to explain about the penstock, then turbine, generator, and speak about the grid. So how the potential energy of water is converted into electrical energy. Each component you have to explain. What is the purpose of dam? It creates a head. What is the purpose of penstock? Movement of water. Okay. So it's a large pipe which is carrying out the bulk amount of water in a certain amount. So then you have to explain about a turbine. Turbine produces mechanical energy. As soon as the water moves on the turbine, it creates the mechanical energy. The turbine is coupled with the generator and the generator produces electrical energy. All right. State and explain Ohm's law with the limitations. So same point is available in the data handbook. Okay, I will show you. What is our requirement is we require Ohm's law, right? So no issue. Directly question, direct answer is available here itself. So refer the circuit diagram. Simple circuit diagram they have given, but not elaborated. Your job is to elaborate it. And Ohm's law, the voltage across the conductor is directly proportional to the current flowing through it, provided all the physical conditions such as temperature, pressure remains constant. Formula is given. If you want, you can plot the graph. In addition to that, you can plot the graph and you can write the calculation of the slope. Slope is equal to delta V by delta I. So that is nothing but the resistance. Try to elaborate it. Fine. Okay. These things can be done. Initially, if you want, you can write V is proportional to I. So V is equal to a constant into I. You can mention the constant name is equal to R. Otherwise, directly you can write. Anything is fine. Hope it is clear to you, everybody. Now let me move on to another question. So please refer the question. For the circuit shown in figure 1, find the current flowing through 2 ohm resistor. First of all, you have to identify how many number of loops are there. There are 2 loops. So mention the direction. Let me call this is 1, I1. I1. Let me call the current flowing through the loop 2, that is I2. Okay, using I1 and I2. So you can see the I1 and I2. So there are 2 loops, loop number 1 and loop number 2. 2 loop means there are 2 equations. 2 equations. Form 2 equations and they try to solve I1 and I2. I1 and I2 you have to solve. So if you want, you can refer my the lecture series of basic electrical engineering. I have solved 3 problems, to be frank. So if you want, if you can refer that particular similar kind of problems are available, try to solve it. 2 equations will be there. We can see that 2 variables. You can use a calculator. You can use the scientific calculator, and you can directly get the answer I1 and I2. So once you get the I1 and I2, how to calculate the current flowing through the CF? Okay, current flowing through the CF I have to calculate. How to make out? I will tell you. Entering current is I1. Another entering current is I2. So this is your current flowing through CF. So we can write entering current means IBC plus ICD, that is equal to ICF. Refer the data handbook if you do not know the KCL, if you are not recalling KCL. So directly you can add I1 and I2 if you add. What is IBC? That is I1. What is ICD? That is I2. If you add, definitely you will be getting the current flowing through CF. Easily you can score it. There is no doubt in that. Fine. Now I'll be showing you question number 3. 3A. Define the following referring the sine wave. So very simple. Let me directly take you the data handbook. As you can observe, all the equations they have given directly with a simple definition. Instantaneous voltage, alternating current, then angular velocity, RMS value. See, RMS value anyway, formula is given. Definitely you can write the definition. Whatever they have asked with the definition only. So these formulas are available. Directly you can elaborate. Your job will be very easy. If you know the concept, you can easily elaborate it. It's not a big deal. Okay. Even average value formula is available. 2 Vm by pi. Average current also 2 Vm by pi. If you want, you can write in terms of decimal also. Like 0.636 Vm or 0.636 Im. Here IRMS you can write 0.707 Im. Like that you can elaborate. Similarly, form factor equation is also directly given. So no issue. Directly you can write. It's not clearing the subject is not a difficult task, especially for 2022 scheme. Then peak factor, maximum value by RMS value. It's very easy only. Everything is given. So you have to recollect it. You have to recollect and try to elaborate it. That's required from your side. Fine. So I think you can solve that particular question. Question number 3B, show that current flowing through purely capacitive circuit leads the applied voltage by 90 degree and average power consumed is equal to 0. You'll be getting 8 marks. Draw the wave shapes of current, voltage and power. So let me show you what is in the data book. So easily you can solve it. Okay, question number 3B. All right, please make a note. See, our requirement is we have to draw one circuit diagram. You may get 1 mark. Circuit diagram you are directly available here. Even the voltage is taken as reference. V is equal to Vm sin omega t. When it comes to current I is equal to Im sin omega t plus this relation we have to prove first. For that purpose, we have to do the phasor diagram. Fine. And finally, we have to prove that P average is equal to 0 watts. So based on the equation, I have derived already. If you want, you can refer the playlist of basic electrical engineering. Starting from V is equal to Vm sin omega t. Okay, this is the beginning only I am telling. Remaining you can refer the detailed lecture. So we have to remember one formula. Q is equal to CV. Fine. We can write C means the capacitance, V is the voltage, Q is the charge. Fine. C into V can be elaborated as Vm sin omega t. Now you already know that current is equal to dq by dt. I'm writing only the formula. You have to elaborate it. Okay. This is the way how to proceed with the derivation. So once you know once you get the value of I, V and I, relation between V and I, afterwards what you can do is you can take the integration, do the integration. Okay. If you do the integration after the trigonometric formulas, ultimately you will be getting the average power consumed in inductive circuit or capacitive circuit or resistive circuit, that will be 0. Same procedure for all the type of circuits, RLC, same procedure. There is no difference. Fine. To calculate the average power, there is a formula will be same only. Don't get confused regarding this. Similarly, there is another problem. An inductive coil takes a current of 10 amps from the supply of 100 volt 50 hertz, lags at the voltage by 30 degree Then calculate the parameters of the circuit, power factor, active and reactive power. So first of all, you have to draw the circuit diagram. So it's a question related to pure inductor. So supply voltage is provided for you. Okay. So current is okay, current. So what is the value of current? Current is 10 amps, right? Current is 10 amps. The supply voltage is 100 volt, 50 hertz. The value of inductance is not given, right? It's not given. Then, yeah. So what they are asking is, you have to calculate the parameters. Parameters of the circuit you are supposed to calculate. Power factor you are supposed to calculate. Parameters, everything you can calculate it. Okay. So you have to refer the particular data handbook. I'll show you. If you are confused with inductive circuit, don't worry. So please refer this particular circuit. Here, the pure circuit diagram is available. Pure circuit diagram for pure inductor is available. Also, the equations they have directly provided. So, relation between current and voltage. So, definitely based on this formula, you can estimate the parameters. What are the parameters? Mean the value of L, the inductive reactance. Okay, all the things you can directly estimate. Fine. Now I'll be telling you the question, explaining you question number 4a. With the help of circuit diagram and phasor diagram, find the phase angle, impedance, and power in the case of RL series circuit. So directly the answer is available in the data handbook. Okay, not direct answer, but hint is available. So here circuit diagram they have directly given for you just for the assistance. You can see the waveforms also. Waveforms. Easily you can draw the waveforms by referring this. But try to elaborate it. That is required from your side because directly we cannot take these points from the data book. But your elaboration is required. Later, you can calculate the impedance using any of the method. You can calculate the impedance. So impedance ultimate answer should be Z is equal to square root of R square plus XL square. Okay, you have to draw that from the phasor diagram only. You can calculate it. Okay. Z is equal to square root of R square plus XL square. Refer my previous video. Definitely, you can refer my playlist. You will be getting the derivation very clearly. So Z is equal to square root of R square plus XL square. That formula you can refer. Fine. So this you can take it as a reference and go ahead. Question number 4b, there is a numerical example, very simple. So we have the resistor. Resistor is 20 ohm. Then inductance is how much? 0.05 Henry. Connected in series, they have mentioned. It's an RL series circuit. Supply voltage is given. What is the supply voltage? 230 volt. 50 hertz. Supply voltage is given. And current is not available. Yes, is not available. Yeah. Find the impedance. Impedance means square root of R square plus XL square. But XL I don't know directly. XL, but I know the formula L omega. L into 2 pi F. L into 2 pi F. But the frequency they have given already. No issue. L into 2 pi into how much? 50 you can substitute. You will be getting XL. Once you get the value of XL, substitute here, compute Z. Next, you need to calculate power factor. Sorry, current. Current is equal to I is equal to V by Z. This formula you can use. Then I'll be getting current. Third one, power factor, cos phi. What is the formula for cos phi? R by Z. This is a formula for cos phi that you can make out. Then power consumed by the circuit. Then circuit voltage drop across E, R and L. So for example, VR, voltage across resistor. VR means I into R. Similarly, VL is equal to I into XL. Only substitution is required from your side. Draw the vector diagram means directly you can refer the manual. In the data handbook, you can refer. Fine. Average power consumed by the circuit will be zero only. That is no issue. So these are the things you can make out. I think you can manage. So I'll be showing you another question. Let me display another question. 3 coil having the resistance of 10 ohm and inductance of 0.02 Henry are connected in star connection across 440 volt, 50 hertz, 3-phase supply. Calculate the line current, power factor, and the total power consumed. Very simple question. You can refer the data handbook first. This is the way how to solve. First of all, I request you to go through the 3-phase connection. This is actually the 3-phase connection. From that, you need to know the relation between line voltage and phase voltage. Line voltage is equal to root 3 times phase voltage, where line current is equal to phase current. You can calculate the Z phase using the formula V phase by I phase. These three formula I require to solve the particular numerical example. First of all, draw the circuit diagram as they have mentioned in the question. Based on the data, you have to draw the circuit diagram same manner. I think everybody can do that. So let me draw the particular circuit diagram. Three coils having resistance and inductance. So three coils RL, RL, RL. Like that, you can draw. Fine. Of course, this is neutral, right? Neutral. R, Y, B. Mark the value of resistance and inductance for each phase. So what is the value? 10 ohm and 0.02 Henry. Calculate the current, line current. Calculate the line current. Okay. Then power factor and total power consumed. Calculate the line current. But what are the things they have given? Line voltage is given. Line voltage is how much? 440 volt. From the line voltage, you can calculate phase voltage. So VL is equal to root 3 V phase. Correct? From the from this equation, you can calculate line voltage. VL divided by root 3. First procedure. Once you get to know the value of V phase, you can calculate the current. I is equal to V phase divided by impedance. Impedance R is available and XL is available. So, sorry, L is available. L is 0.02. Therefore, you can calculate XL. XL is equal to, what is the formula? 2 pi F into L. L into omega, right? L into omega. L into omega. So you can get the value of L. Then substitute here, you will be getting current. Once you know the value of current, you can easily calculate the power factor. So power factor you can calculate. Very easily you can calculate R by Z, direct formula. No need to know the value of current. Directly you can calculate. Similarly, power consumed. P is equal to root 3 V phase. Sorry. P is equal to root 3 VL IL cos phi. Anyway, root 3 constant. VL is available for how much? 440. IL we computed because line current and phase current is same only. Cos phi we just computed. Cos phi is the power factor. This is the thing you are supposed to make out. So moving on to module 3. So I'll be giving you some guidelines. Neat diagram of DC generator. Construction. Construction means you have to explain the entire half, the cross-sectional area, the cross-sectional area of that particular DC generator. In that you have to mention about the field assistance system. Okay. Then you have to mention about the yoke, commutator, brushes, that particular circuit diagram, that particular the half section, the cross section diagram you are supposed to draw. Then you have to explain what is the purpose of yoke. It's an outer covering. Okay. It encloses the entire the structure of that particular DC generator. Next you have to explain about the field system. The purpose of field system. What is the purpose of it? You can use temporary magnet or electromagnet. Then you have to speak about the armature winding. Okay, it's a conductor. It is made up of with a number of windings. There are two types of winding: wave winding, lap winding. Try to elaborate it. So another one is actually derive the expression for the torque developed in DC motor. I will show you the data book how to make out. Okay. So torque equation you need to know. Similarly, you need to know the basics of generator. I will show you the data handbook. For your information, they have given the EMF equation. Very easily you can remember. And mentioned about the lap winding and the wave winding. So lap winding A is equal to the armature conductor per parallel path is equal to number of poles. And wave winding, the armature conductor per parallel path is equal to 2. Okay, those things they have given directly. So series generator, speciality of series generator, then shunt generator. Sometimes some questions may be asked, what are the types of DC generators? You can use the particular circuit diagram and the basic equation to expand, to elaborate. And even compound motor also they have given for you. Even motor, okay. Torque equation is directly given. So your job is to derive this torque equation, right? Anyway, you know the torque equation. Definitely you can make out. It's not a big deal. Even shaft torque, angular velocity, everything is given. So your job will be minimized. Only you have to study the derivation. Okay, then definitely types of motor is given. Look at this. These are the types of motor. Relevant formulas are available. So if the question is related to DC shunt motor, you can directly draw the circuit diagram, right? If you know the circuit diagram, you can analyze based on your concept, based on the basic knowledge, you can analyze it. Fine. Yeah. So let me come back to the question. Yes. So these two things you can manage it very easily. Okay. Next is actually the questions related to EMF equation. Already shown you know. So you have to mention the formula. E is equal to Zn phi by 60 into P by A. Directly you can mention. Fine. So question number 6A. Explain the various methods used for controlling the speed of DC series motor. Speed control you have to elaborate. Okay, see two methods. Okay, for series there are two type of methods. One is armature speed control, other is the field, based on the field control, armature control as well as field control. If the speed control is below rated speed, you have to go for armature speed control. If the speed control is above the rated speed, you need to go for the flux control, field or flux control. All right. So another question is related to shunt motor. See, look at this. First of all, you have to draw the circuit diagram, shunt motor. Take the formula first. Shunt motor means draw the circuit diagram which is given in the data book first. Based on that, you can easily analyze. So first of all, a shunt motor. No, shunt motor means so we have armature, correct, and we have field winding. Okay, we have the input supply. What is the supply they have given? 250 volts they have given. And the current also, the total current is 25 amps, right? 25 amps. The armature resistance is how much? 0.5, right? So Ra is equal to 0.5. Similarly, RSH is given how much? 125. Oh, all the things they have directly given. It's not a problem. It's a wave-wound armature. Wave-wound means A is equal to 2. Directly you write somewhere else. Then there are 30 number of slots. Each slots are having 10 conductors. Therefore, total conductors is equal to Z is equal to how much? 30 into 10. All right. If the flux per pole is how much? Phi is equal to how much? 0.02 Weber. Calculate the speed, torque developed and power developed. Okay. So total current is actually 25. But I don't know the armature current. Okay, current through the armature, I don't know. And even ISH also, I don't know. So first you calculate ISH. ISH is equal to V divided by RSH. Once you get to know the ISH, you have to use the KCL. How to use the KCL? Total current is 25 ampere. Correct. Total current is equal to IA plus ISH. Fine. So once you get to know the equation, IA can be calculated. I minus ISH. Then later what you can do? What you require is you have to calculate the speed, right? For that purpose, what is the requirement is back EMF is required. Okay. So you already know that V is equal to EB plus IA into RA. So EB I can calculate. EB is equal to V minus IA into RA. All the formulas are available in the data book. Please refer that. Use your common logic. So once you get to know the value of EB, then I know the formula. EB is equal to Zn phi by 60 into P by A. Correct. Anyway, all the A is available, P is available. Then phi is given. Z is just computed now. EB I computed. From this you separate the value of N. That is the speed. Torque developed. Torque equation you already derived. A torque equation. Refer the formula and do that. Power developed. How is the formula of power developed? Power developed is equal to, okay, EB into IA. EB into IA. These are the formulas. If you know the logic, very simple fashion, you will be getting 8 marks. Without putting more time, you are able to get 10 marks. Clear? Another question is actually derive the EMF equation of DC generator. Formula is available directly. Directly, if you apply the Faraday's law, even Faraday's law formula is also available there. So if you know both, easily you will be getting 4 marks. Now, questions from transformer. Derive the EMF equation of transformer. Similarly, explain the three transformer we can see. EMF equation of transformer. Fine. derive the EMF equation of transformer, obtain the voltage and current transformation ratio. So you have to derive the EMF equation. So I'll be showing you the particular EMF equation of transformer. Yes, let me take you the particular diagram. So this is actually the parameters. EMF equation is directly given. Okay, so you can derive based on the Faraday's law. Fine. So once you know the EMF equation, you have to elaborate the terms. Terms are already variables already given in the upper side. Okay, in the top segment. Once you get to know the EMF equation, you can directly write the expression for transformation ratio by taking the ratio of E2 and E1, or taking equation 1 and 2, you can take the ratio. Depends. You will be getting the transformation ratio. These are the things they have asked, but you have to elaborate and reach to the answer. That is only the job from your side. Hope you are understanding. Yeah, now I'll be showing you the rest of the question. Now, explain the types of three-phase induction motor. This is a question from induction motor. I think the question has been come from another module. No issue. So there are two type of another segment. Okay, there are two type of induction motor. One is slip-ring induction motor. Slip-ring induction motor. Another one is squirrel cage induction motor. You will be getting the basics from the data sheet. You can refer that. Another one is actually the transformer efficiency related to transformer efficiency calculation. Transformer is rated 100 kVA at its full load copper loss is equal to full load copper loss WCU, how much? 1200 watts, and its iron loss WI is equal to how much? 960 watts. Calculate the efficiency at a full load and the unity power factor. So you can use the formula of efficiency, eta. Eta is equal to, what is the formula? VI cos phi, VI cos phi into 10 to the power 3. Okay. Eta is equal to KVA output in KVA, okay, divided by KVA plus X square into WCU plus WI. This is the formula. Anyway, 100 kVA directly they have given. So if you want, you can convert into volt ampere also. So 100 kVA. If you want, you can convert volt ampere divided by 100 into 10 to the power 3 plus. So X is the load factor. Okay, X, fraction of load. See, the X already mentioned, right? First one, efficiency at a full load. So X will be 100%. That is equal to 1. 1 into, what is WCU? WCU will be 1200 plus WI, iron loss, 960. If you substitute, you will be getting the answer. Similarly, if it is asked with the other type of load, like X is equal to 25%, 0.25 you have to take. 25% means 0.25. So this is like power factor is unity. If it is some other power factor, means you have to mention the power factor. So that formula I'll be showing you. Okay, let me show you the formula regarding the transformer. The efficiency calculation formula is directly given. I'll show you the formula so that it will be easy for you. See, this formula you can use. X into KVA into 1000 into cos phi divided by X into KVA into 1000 into cos phi plus WI plus X square into WCU full load. If you know this formula now, so again, I think I have not mentioned about cos phi because I considered only for power factor is equal to unity. That is why I haven't mentioned cos phi, because it's a unity, right? For power factor maximum means it's a unity only. So directly you can directly make use of the formula, substitute accordingly. So put the value of X. If it is 100% means put 1. KVA means what is how much they have given into 10 to the power 3 or 1000 you can mention. Then you have to mention about the power factor cos phi. Fine. Then X square means a fraction of load. WI means already directly given in the question. Use the formula and get the answer. Direct substitution, nothing in that, nothing more. All right, yeah. So that point, I think you will manage it. So first you write the formula, later come back to the parameters, draw the parameters. Okay, that part is finished. Now let me move on to another segment. Explain the various losses of transformer and how to minimize the losses. Transformer losses. Okay. Transformer losses. There are two types of losses that is also available in the data handbook. See, the losses can be broadly divided into two types. What are they? First one is copper loss. Copper loss. Another one is called iron loss. Copper and iron loss. Again, iron loss is divided into hysteresis losses and eddy current losses. Even copper loss, I can talk about primary side and secondary side. So formulas of hysteresis loss is directly given. Eddy current loss is already given. So how to minimize the losses means for to minimize the eddy current, we need to provide lamination at the core. So for minimizing the hysteresis loss, you need to select silicon steel type material, which is having the very less value of hysteresis content. Like that, you can elaborate it. Everything is available, but your job is to elaborate. Clear? Okay, now moving on to another question. With the diagram, explain the concept of rotating magnetic field of induction motor. Here, what we are supposed to do is please refer the content related to three-phase induction motor. Yes. So I'll be showing you. All the equations are available, or it's required for us. Rotating magnetic field. Okay, no problem. Rotating magnetic field. Okay, bridges and all not required for us. Okay. Rotating magnetic field, they haven't given anything about rotating magnetic field. So there is a derivation which I already explained in 2 weeks before. I have made a video on the explanation of rotating magnetic field that you can refer. So ultimately, what you are supposed to do is you have to elaborate the Faraday's law of electromagnetic induction, and you should get one derivation. You have to go for one derivation. Phi is equal to phi resultant is equal to 1.5 into phi r. This is a derivation actually. Okay, this derivation you are supposed to make out. Okay, then you will be getting full marks. So another type of question. A three-phase induction motor with the 4 poles supplied with the alternator having 6 poles at 1000 RPM. Calculate the synchronous speed rotating speed of the induction motor with the slip is equal to 0.04 and the frequency of rotor EMF when the speed is 6000 RPM. Same problem I solved in the lecture series of basic electrical engineering. For that purpose, what you are supposed to do is first figure out the formula. What are the formulas they have provided? See, synchronous speed formula is how much? 120 F by P, and a percentage of slip, that formula is already given. Fine. The frequency of the rotor current or rotor induced EMF, that is F dash is equal to SF. If you know rotor speed is equal to N is equal to NS into 1 minus S. If you know the formula properly and you do understand the question, same question you can refer my playlist. It's available in the playlist of basic electrical engineering. You'll be getting that part if you refer that. I will share the link also. Fine. Along with that, I will be sharing the link. Okay, if you know this formula, no, you can easily manage that particular numerical example. Fine. Okay. So another one is module 5. From module 5, all the questions are theory type questions only. First, let us see what are the things they have given in module 5. So refer the module 5. The useful information which are given from the module 5, they have given like a domestic wiring, like a two-way control of lamp they have provided. Similarly, three-way control of lamp is also given. Two-way control of lamp application is actually you can use in staircase, you can go for in bedroom, like one single lamp which is controlled with the help of 2 separate switches at a distinct position. Three-way control of lamp will be using an intermediate switch. It is applicable where the long corridor is available. This type of wiring is also known as jail wiring. Even truth table is also given for it. Sometimes question will be asked directly. Then regarding the tariff, the calculation of tariff, two-part tariff is available. So direct calculation you can go ahead. Now let me show you the question. Yeah, with the neat circuit diagram and two-way control and three-way control of lamp. Directly you can take that particular table and you have to elaborate it. That is only the job. 4 plus 4. Okay. Similarly, explain the working of fuse. Why fuse is required. Okay. Circuit diagram. Refer that data handbook. Similarly, what is earthing? why earthing is required. Earthing is mainly for one of the personal safety device or personal safety system. The non-current carrying metal part or non-current carrying conductor will be appliances will be directly connected to the ground. Since the ground is a universal acceptor, it will receive the fault current. There are two types of earthing: pipe earthing and plate earthing. That you can elaborate the pipe earthing in detail. Diagram is mandatory. Similarly, define unit. So it's a commercial unit of electrical energy. So 1 unit is equal to 1 kilowatt hour. Fine. Your two-part tariff, you can directly take the information from the data handbook. This the module is very simple. I request everyone to score 20 out of 20. What is electric shock? Okay, you can write general. It's a sudden discharge to the sudden discharge of electricity towards the human body. That is called electric shock. Then what are the preventive measures? At least 10 steps you have to mention. Use the glove, and the earthing should be proper. Then the broken part should be removed. Like that, there are different strategies or different criteria. Those things you have to follow. And list out the power rating of appliances in your house, like PC, laptop, printer, etc. You prepare a checklist of that. PC maybe operating with 100 watts, and a laptop. What is the rating of a laptop, printer? Likewise, you prepare a list. Incandescent lamp, 100 watts. CFL, you can mention fluorescent tube is 50 watts. LED, maybe 5 watts. Like that, you can prepare the table. Any confusion regarding this particular thing, you can ask with me. I am ready to help. Thank you for watching this video. You refer the data book first very clearly. Definitely, you can crack the examination with a very good score, very good CGPA, SGPA. All right. Thank you so much for watching this video. All the best for your examination. Have a great day.